Today's lesson is using the second method of solving quadratics, and this method is called solving quadratics using the square root property. Quick recap from the previous lesson. Quadratic form, or standard form of a quadratic, is in the form of ax squared plus bx plus c is equal to 0. Each term has a name. This term right here is called the quadratic term. This term in the middle is called the linear term. And this last term, the value of c, is called your constant term. So when there is no linear term, that would be this term right here, you want to solve using the square root property. The notation for the square root property says that if x squared is equal to c, then you can take the square root of both sides like so, and you're left with the answer x is equal to positive or negative square root of c. Solving this using the square root property will always yield two solutions. All right, the example set. We're going to start off with easy examples, and we're going to move into ones that are a little bit harder. Number 1, we have x squared is equal to 25. So we want to always make sure that we have the squared term isolated, which is this term here. In this case, it is isolated, so take the square root of both sides. X is equal to positive or negative 5. Number 2. Number 2 has an expression that's squared, but this is still the entire squared expression. So this already is isolated. Okay, so our term of x minus 2 is in parentheses squared, and that's equal to 36. So like I mentioned, the squared term is already isolated. We take the square root of both sides. If you take the square root of a squared term, such as this one, we're going to be left with just x minus 2 is equal to plus or minus the square root of 36, which is 6. Now here's where you have to pay close attention, because it's very easy to just, or in this case, add 2 to both sides and add it right to 6 and be done. But that is not how you go about solving this one. You have two solutions here. So the first solution says that x minus 2 is equal to positive 6, and the second solution says that x minus 2 is equal to negative 6. So you have your positive answer, you have your negative answer. Then you solve for x. Add 2 to both sides over here, we end up with x equals 8. Add 2 to both sides over here, you end up with negative 4. So your two solutions are x equals 4 and 8. Oops. Number 3, we have 2x squared plus 128, and this is equal to 0. We need to isolate just the squared term. I'm going to start off by subtracting 128 from both sides, leaving me with 2x squared is equal to negative 128. I'm still isolating this term. Divide both sides by 2. X squared is equal to negative 64. Square root both sides. We have x equals positive or negative square root of negative 64. Now, this is what we learned the last lesson. We have a negative sign underneath the square root sign, so we are going to use imaginary numbers. To start off by simplifying this, I'm going to rewrite this as plus or minus, and then I'm going to take out my negative square root of 1, so I have I times the square root of 64. After I have I times the square root of 64, I can recognize that 64 is in fact a perfect square. Oops. So I can simplify this one step further for plus or minus I times 8. And this is the final answer, but I just want to clean this up and write it as plus or minus 8 times I. Also, recall that the plus or minus sign is in front of the radical, and then we simplified the radical to 8i, so the plus or minus sign has to still be in front of what the radical was. Okay, the radical was negative square root of 64. 8i is the simplified version of that. Make sure that plus or minus sign is in front. Number 4, subtract 3 from both sides. So we have 4x squared is equal to 16. Divide both sides by 4. And we now have the isolated expression of x squared is equal to 4, where you can take the square root of both sides, and your answer is x equals plus or minus 2.